Live from New York, it's Ask an Engineers!
Hello everybody, welcome to another fabulous, fantastic Ask an Engineer show. We're broadcasting live from downtown Manhattan in the Adafruit cluttered headquarters. I'm Lady Ada, I'm the engineer, and with me is Ayah.
Lady Ayah.
Lady Ayah Bdeir, who's come to us from all the way a mile uptown. Wow, such a long trip to get here on the two. Who will be showing off awesome Little Bit stuff, which is her company. Yay!
Yeah.
So we have a fun, packed show full of Little Bits and Ayah, and you can ask all sorts of questions about Little Bits and stuff,
Yep.
and how exactly you design magnetic connectors that also pass current. It's kind of a difficult problem that you have solved.
Fun stuff, yeah.
Okay, what's on tonight's show?
Okay, on tonight's show, the code will be bits. 10% off many things. We ran out of stock of Little Bits, but you can still use the code bits to get 10% off many things in the Adafruit store. We will talk about this awesome, massive show and tell. It was intense. Some news around the web. Michael Shiloh joined the Arduino team. We went to Hope today. Becky had a cool project. Ask an Educator on the website. Part Finder Friday. Not going to do too many new products, but we do want to talk about Raspberry Pi badges. Some improvements to the Adafruit Learn system. Ayah, did you see our new Learn system yet?
Not yet.
Maybe we'll give you a tour. We will be talking to Ayah from Little Bits, from its beginning. A little bit about Ayah, from the Open Source Hardware Summit, to the Open Hardware Definition, to the logo that the community decided on, to all the great news and videos and everything that I've seen around the web. You were at TED, you're a TED fellow. We have your awesome new commercial video.
Yeah, we just released that last week.
Yep, we have it here. Everyone's going to be able to see it. I have an old photo of some of the original Little Bits.
Yeah.
Ooh, we can talk about that. We're going to show
all
sorts of Little Bits things. I have some things from your website. You can talk about all the fun things. I know you brought something that's not even released. And people are going to see it tonight.
Sneak peek.
We're going to answer your questions. We're going to have a trivia question. We're going to have a cat.
Oh, I'm going to totally put Little Bits on the cat.
We're going to have, yeah, all that and more, all on Ask an Engineer. Okay, whew.
Yeah.
This is a show.
Why are you even talking? Get off the screen.
I'm getting off the screen.
Why are you even here?
I am.
Ladies
Remember,
only.
code is bits.
Yes.
And,
Little Bits are going to be in stock starting Monday.
yeah.
Yeah, we're going to try to get some
Yeah.
stuff.
All right, so I want you guys to try to remember and talk about what was on the show and tell.
Okay, first up was Jeremy, who's a long-standing member of the show and tell community, and he. What?
Speak up.
I said, what did Jeremy had? He had
the little GPS thing.
yeah, the little GPS in the
tin,
tin. He showed off his intervalometer, and he said he was excited to talk to some TSA Bob people. After that, we had Howland with his robot. He said it was called the Hero.
Yeah, it's a Hero from Heathkit. That's from
It's
1983.
a massive, like $2,000 robot kit, and it's cool. There was like a little number pad. You could type in your hex code and control it, and it could could speak. It had like a gripper arm.
It's from the 80s.
And it's from the 80s, so it's like super retro. After that, we had Quinn, who had a little Android robot dice rolly thing, which is cute. So
LED in the eyes.
LED in the eyes. And the cool thing was, like, instead of trying to like shove an Arduino into this, taking an Arduino and programming it with a programming Arduino ISP, programming in a chip, and stuffing just the chip in. Because, like, you know, the Arduino, like, if you don't need the headers of the USB connector, you can just like burn the bootloader or burn the program directly on, and so then you can stuff it into this little cute thing. After that was.
Well, we tried to have Alexis who had it looked like either a time machine or was a homemade CERN accelerator.
And there was Matthew. What did Matthew show?
Matthew showed his LCD
mods
to work with the Raspberry Pi, which is really cool.
Raspberry Pi, and then Chris Courtwright finally showed up with his like mega crazy octopus pool 3D printed. Whatever.
Yeah,
controller,
and he used Jeremy's
LED.
RGB boards to light up the pool.
Yeah.
And one of the cool things about his project was he used an Arduino to determine if the pool level went too low, it would automatically use our flow valve to fill up the pool again.
Yeah, and then the strips, the water level meter strips. That's cool.
Yeah.
Very intense. Uses like one of everything in the Adafruit shop, so that's cool.
So that was a big show and tell.
Yeah.
That was massive. That was awesome.
Okay.
Tell everybody how they can be on the show and tell.
It's super easy. Just go to my Lamore Freed, Lady Ada, Google Plus page, and once a week I post up and I say, hey, post up here in the comments to be added to the Google Plus circle, and then I'll add you because we cannot have the Google Plus. We can't have the Google Hangout invite everybody. We have to invite a circle, and so you have to be added to the circle ahead of time. So do it now, and then anytime in the future when you have a project to show off, you'll be invited.
For the folks that show up, we're starting to give away badges based on some of the projects, like we're giving away an Android badge, a Raspberry Pi badge. We're going to have an as seen on the show and tell. There's a lot of people at maker fairs and hacker spaces that say, oh, did you see my project? It was on the show and tell. So soon we'll have some stickers and badges for that.
This actually looks a little bit like the Hero Robot.
Yeah.
Like it actually has kind of that little like square head with like the teeth.
Okay, we're going to blow through the news. We're not going to do new products this week. We're just going to go through some news. But there is some big news in the world that I think is very exciting because we like to celebrate people.
Okay.
Michael Shiloh is now part of the Arduino team.
Yeah, he's the community manager, yeah?
You know Michael, right?
Yeah.
Okay, great.
I see everyone knows Shiloh. Everyone. Michael Shiloh is like a cornerstone or, I don't know, bedrock or like whatever kind of architectural metaphor you want to use for like the maker community, especially in San Francisco, California, Bay Area.
He's been traveling around doing
He's
his
been traveling.
Yeah.
He was at OpenMoko before OpenMoko didn't really work out. And he's been doing Teach Me to Make, which is really interesting because it's all about, you know, instead of like, I mean, like, you know, everyone loves like Raspberry Pi and Little Bits and Arduino, but there's some people who like, you know, they want to basically teach these kinds of skill sets without having to even spend $1 or $2 because the kids just don't have that much money or the parents don't have enough money. So he tried to figure out ways to teach like electronic concepts using like trash, like junk that you have around the house. And I thought that was really cool because like what can you do with just like rubber bands and twine and like paper cups
and paper clips and stuff like that.
Yeah, so like and like a battery. So I think that's really cool, and he's the perfect person to do the Arduino community management. So I'm really glad to hear that he's been brought on. Yep. Community liaison. Sorry.
Yeah, it's exciting. He's a great person, and they're very lucky to have him, and it's going to just make Arduino even better.
Yeah.
Next up, we were at the Hope Conference today, and you hung out with Eric from Seed.
Yeah, we were there a little briefly because we had to come back here to get ready for the show. But I went down and we hung out a long time with Hal and Eric Pan, who were at the Seed Studio booth. A lot of hacker spaces had booths there, which is really exciting. Like, it's really neat to see how, you know, I mean, I've been going to Hope pretty much everything except for the first Hope. I think I missed the first one. But, like, I've been going for like 10 years, and so, or maybe even 12 years now. But what's really neat is how hacker spaces have changed, but they've, I think, in a sense, become more inclusive and more productive. I mean, I don't want to say productive as in, like, member society, but like there's more stuff coming out from hacker spaces. Like when we had hacker spaces before that were more like hackery based and maker based, there wasn't as much like publishing and sharing. I mean, like some people would.
Well, there weren't physical projects. It was like who can hack someone's Linux box.
Yeah, I mean, like some people write articles.
They've become
they're more. It's not that they're productive. They're prolific. That's the word I was looking for. Good work there.
The third language.
Yeah. Well, but it means you can find the words easier. So they're much more prolific and I think also much more inclusive. And I think like instead of just like writing articles for frack and doing drugs, which there's nothing wrong with that. You know, there's a lot of history of that too. I think they're doing workshops and like sharing tutorials and doing projects together and building 3D printers and like that's, you know, like I kind of like that. Yeah. Like I think like maybe, you know, they're doing a better job.
Yeah. Also, there's more diversity and it's more inclusive. I'm seeing a wider variety. I've gone to Hope a bunch of times. I'm seeing more different types of people getting involved, building things, sharing. Yeah. So anyways, that's fun. Good. For the other day, we're going to keep moving on. Next up, everyone please go watch Becky's video. She outfitted her dog with a GPS. Becky got a dog, so now there's a lot of dog projects.
This is going to be a lot of dog projects.
It'll tell you how far and how long you walk your dog.
Yeah, so she has to walk her dog like 2 miles. She wants to walk her dog 2 miles a day. So yeah, it's basically so she put a GPS module and an OLED, and there's a little bar graph, and then when she goes outside, you know, the bar graph, you know, and you program it in how many miles. It's like 1.5 miles, and so it'll show until she's done walking the dog. So she has to, because the dog needs exercise.
Yeah,
big dog.
So go watch the video. We'll have Becky on next week, I think, and we'll also have a bunch of products and everything. We're just going to blow through these. Since you're both here, I thought I would add one of these things. So we have a segment called Ask an Educator on our blog, and this week was how can I explain a sine wave to a 13-year-old? So
that's tough.
Yeah, tough, right? It's hard.
I like the person who I think somebody said if you put an LED on a bike wheel and you took a photo of it, that's a good thing because then you can actually do that. You can take it like a throwy and tape it to a bike wheel and then pedal and then take a long exposure shot and it will be a sine wave.
Yeah.
But they won't understand how the like the voltage like as.
No, but I think they're it's like just mathematically, what is a sine
Yeah.
wave? Where does it come from? It is a little hard to understand.
It's hard to understand.
What a sine wave is. So I think that's pretty cool.
Okay, moving right along.
But I'll think about other ways to do it. It's
Yeah.
very difficult. I
Yeah,
remember
it's difficult.
and once you add voltage and current, that gets so complicated.
Next up, you had a Part Finder Friday. You want to talk about this part that you wrote about?
Yeah, I did. I'm trying to like get back into doing like Part Finder Friday and like Tutorial Tuesday, although like things have been so crazy. I mean, we've been putting out so many products in the store that it's kind of taken up all my time. But this chip is the TVP 5150. And the way I found this chip is actually because we carry these really cute little television displays, and they're basically TVs, literally. Like you plug it into like a VCR or whatever, and they're little TVs. And I was kind of like, wow, like what are they using to drive this? Because I thought it would be like an FPGA or CPLD or or some more complicated chip. But it's actually this TI chip, and it's a little expensive. It's like a $4 part, but it's kind of neat. It actually it's very basic. All it does is take an NTSC or PAL signal, decode it, and then pump out like 8-bit digital with an H-sync and a V-sync and a pixel clock. So it's basically specifically designed to drive low-cost displays. So it's basically this chip is designed just to do this, and it's actually kind of cool. So like if you have a fast microcontroller, like an ARM that's running at 72 megahertz or something, or an FPGA, and you want to get a video in, this chip would actually do a very good job of getting video in without much effort, or like a Linux computer or something, like anything where you could grab the 8-bit data very quickly. You can take television signal or like from a camera, so it might be an easy way to add video to a project. So I thought this chip was pretty cool.
Okay, next up, some big news. We got official permission to make Raspberry Pi badges. There's a lot of people getting these, using these. This is a nice photo of them. And,
yeah, I like that photo.
Yeah. And,
Like you took that nice photo.
Yeah, and so, anyways, we have
the
these.
Pi patch.
Yeah, we have these. We'll have stuff for workshops soon. We're not doing new products this week, but we have them. Okay.
They're pretty.
Next up, real quick, some updates in our learning system. Actually, we can show this to Ayah. So we debuted the Adafruit learning system
2 weeks ago.
2 weeks ago. We couldn't find a tutorial system that fit our needs perfectly. So, like all good makers, we decided to make our own. So this is an effort led by Justin Cooper, Tyler Cooper, Daigo, Lady Ada, myself, and it's
And MOSFET.
and MOSFET sometimes.
Says web design.
And the goal is to make the best tutorial system in the world.
Yeah.
It's a big goal.
I'm very picky.
Yeah.
And
So Lamore's our number one customer.
I was like, I demand that this tutorial system does this and this, and they did it, and it's great, and it's like I'm really happy because like instead of spending time in Dreamweaver, I'm spending time doing tutorials now.
Yeah. So I'm gonna do a quick demo.
So is it live?
Yeah.
Super live.
Yeah. So
We're
I'm gonna
gonna
do a
show
quick
it
demo.
right now.
Yeah. So it's all HTML5, so it resizes itself and all this stuff. This week in the updates, one of the things that we did is we added super fantastic PDF support. So the PDFs look gorgeous.
Yeah, but go back to the previous tutorial to see the gist.
Yeah, I was going to say, the other thing we added was the gist feature. And the gist feature allows you to put in live code that's on GitHub and automatically pulls into the tutorial system. And when you print it, it says when it was last saved. And when you change the code on GitHub, automatically flows to the tutorial and to the PDF. So which one do you want to show?
Also, we have the guides drop down now.
Have the guys dropped down?
So you can go to a Raspberry Pi topic.
Yeah. So you want to go to Raspberry Pi?
Yeah. So I can show this gist thing. So then if you go to the email notifier, so click on...
Email notifier?
Yeah, and then click on Python script.
Python script.
So this is a gist, which means, and you can barely see here, it comes directly from GitHub, which means for more complicated code chunks, I can edit it. So you can go to, click on this gist, and it will take you to the gist on GitHub. So this is a way to do code that might want to be revised. So hopefully eventually we'll have all of our clips be gists, and then you can view raw.
Yeah.
But I really like it as I mean, we already have code chunks we can put in, but I like the idea of having automatically can you go back automatically generated, and then if you go to download PDF,
the PDFs look beautiful.
Nice. The PDFs look really good. We're still working on tweaking a couple little things, but then if you go down to this like 9th page or something, you can see the gist. And it's super smart, and you can even still click on those links. So you can click on View Raw. Oh, go back up. So you can click on View Raw, and that link will still take you to the gist.
Nice.
Yeah.
So you can have, and what we'll have is a system that automatically checks like every day to make sure, because the PDF has to be regenerated.
Yeah.
The tutorial is live. Like that gets pulled live, but the PDF does have to be generated.
And we also say when it was last updated too, so people know.
Yeah, we added the last updated.
Yeah.
When we tweaked the PDFs a little bit, we added on the right hand side the products featured in the guide, so you have a quick link to what it is that we're talking about.
These are all the pie categories.
That's awesome.
Trying to think what else we added.
And so, anyways, we're our entire system is going to be this. So we're adding new things every single week. Justin and Tyler are doing a fantastic job. All the tutorials are beautiful. They work on all systems, iPhones, iPads, Android devices, anything with HTML5. It automatically detects the screen sizes and optimizes for all sorts of things. And we love it. We feel like we have a great place and a great system for tutorials. And
Well,
you know how it is. It's tough, right? Like you have to do tutorials too.
We have to do. We started the page on the community platform where we have sort of step-by-step guides of how to do things, but it's still wonky. It doesn't work great. There's still a lot of tweaks that we have to do to it.
So anyways, this is Adafruit Learning System, part of Adafruit Learning Technologies, and we're putting up all of our stuff there. And
we're slowly porting all of our tutorials from the wiki, which I'm glad we don't have to do anymore because it was very clunky, and moving it to this nice, elegant system. The thing is we had with the wiki is the nice thing about the wiki is other people can come in and edit it, but in the end, people pretty much didn't edit it. It was just me, which is fine, or like people in the team, which is kind of, I can do that. We can give permissions in the back end. There's a permission system so that the team can update the tutorials, which is really good. We have like 6 people who are editing tutorials, and like things change. You want to update them and correct them. But basically, generating PDFs is so hard.
Yeah.
It's such a different technology than HTML that getting those two things to intersect is just kind of like a nightmare. And so one of the things we worked on is trying to get PDF generation immediately. Like instead of let's get everything working and then add PDF support, we want to add PDF support early because as we make the system more complicated, I want to make sure that we retain the PDF support.
Okay.
That's a biggie for me because it's like wiki to PDF, impossible. Very, very hard.
And it's so much better, and you can keep a record of them. You can do them on planes.
Yeah, you can. Like some people want to print it out or download it for later viewing, and this is
educators want to use them for workshops.
Yeah,
That's the way it is.
exactly.
All right, so no more stuff. It's all little bits.
Okay,
That's
let's
the
do
show.
20 minutes of warm up.
That's
great.
Okay.
So-
I'm all warmed up.
It's little bits time. You're here.
I'm here.
It's fantastic.
That's a great photo. Where'd you get the photo taken?
Actually, it was a portrait shot by a photographer called Mark, who shot it at iBeam.
Oh, that's good.
So speaking of, so introduce yourself.
Okay.
So my name's Ayah.
Okay. Front center.
Front center. My name's Ayah. I am an engineer. I was with Lemore at the Media Lab at MIT, but was 1 year behind her, or 2, or 1 year. And I've been working on Little Bits for a number of years now, and recently, September of last year, it became a company and became a product, so we're very excited about that. And I live in New York. Actually, our office is like 12 blocks away or something like that. And yeah.
That's so cool.
And Adafruit is one of your distributors. We love Little Bits.
Adafruit is one of our distributors. Adafruit, I think, is our favorite distributor.
Oh, that's good. You say that to all the distributors, and you should. Okay. Yeah. All right. Well, Lamore's going to ask you some questions.
Yeah. Is there anything in particular that you wanted to start with?
Well, we're going to start with how I think some people might know you. So, the Open Hardware Summit, you were the co-founder and chair. What was Open Hardware Summit? Why did you work on this event?
So I've been working on Little Bits for a number of years now, and when I was working on it, one of the questions that I struggled with is I wanted to make this hardware and I wanted to make it open source, but I was also concerned that just putting the files online maybe doesn't mean that it's actually open source, and I had all these legal questions, and I was emailing with some friends, including Lemore and Phil, including friends at SparkFun and Arduino, a bunch of other places, and all of us had similar questions. And so I started working with Creative Commons as advisors, particularly with John Wilbanks, and I said, okay, whatever I'm going to learn from Creative Commons, I'm going to try to share with other people. And so I hosted a workshop at iBeam called the Opening Hardware Workshop, where we invited about a dozen or so people that are doing open source hardware in New York and the area, and John Wilbanks and Tim Green, who was the lead counsel, legal counsel at Creative Commons, gave us gave a talk basically and taught us all about how we could approach open source in hardware.
Yeah, it's a really good talk. I went to it, and Phil went to it, and Bunny was there.
Bunny was there,
and it was really cool because it was like the first, like, what the thing is that like lawyers, they're like very smart, but they're also kind of hard to pin down.
Yeah.
Sometimes, like, oftentimes, like, I would ask people who knew about the law, and I'd be like, well, what is the law about, like, circuit boards? They'd be like, well, I don't really know.
Yeah,
and so this was really nice to finally get someone where it's like, okay, you can't leave this room until you tell us all the prior cases that have to, you know, or like.
And he gave some really good examples.
Yeah.
He had a lot of historical examples, and I'd been working with John for a while, so he'd kind of been primed at all the issues that we go through as a community, and they were super well prepared. It went so awesome, and so out of that, I decided that we should do this event bigger. And concurrently, at the same time, Alicia Gibb, who was at Bug Labs, was talking to Peter, her CEO at the time, and they were talking about doing a conference, an open hardware conference. And so actually, you told us to talk. Told Alicia and I, you know, Alicia wants to work on a conference. You know, Ayah wants to work on a summit, and then we ended up working together, and we co-founded the Open Hardware.
I hope I did. I don't remember. That was many years ago.
I feel like it was you. It was
someone. Probably Phil.
Maybe it was Becky actually. It may have been Becky. I forget now.
One of my jobs is play the matchmaker behind the scenes, so I'll give someone else credit always. Yeah. I'm sure it was Becky or Lamore.
I think it was it was either Phil, Lamore, or Becky. So one of you guys put us together. But basically, so Alicia and I have co-founded the Open Hardware Summit. The first year and the second year was at the New York Hall of Science, a couple of days before Maker Faire, and Make supported us a lot, and the New York Hall of Science supported us a lot. And
you became a Creative Commons Fellow, is that?
I became a Creative Commons Fellow, and I started doing more of that research. And the Open Hardware logo was one of the projects.
I'm going to get to that.
Oh, sorry. I'm
Next up. Myself. So out of all this became the open source hardware definition.
Yeah.
Correct.
And we all worked on this for a really long time.
That was...
Well,
we did it. We did it.
It was
well, so here's the thing. Can I ask a hard question?
Yeah.
Why a definition and not a license? Why didn't you guys come up with a
license? Thank you for asking. So out of the at the opening hardware workshop, the recommendation from the Creative Commons folks was don't go to the law, because the law is going to overcomplicate the things that you want from it, and instead try to get consensus as a community on what you want open hardware to mean.
Yeah.
And so first, come up with a statement of principles and a definition, and then out of that you'll be able to sort of either lay down whatever legal terms we want out of it or not. And we basically started out of that workshop. We decided to do a statement of principles and definition. It was on a wiki, and a bunch of us were editing it, and particularly a lot of the editing was happening with Wendell, Dave Mellis, and a couple of other people who did a really good job with it. And then we started releasing every version. We released the version 0.1, 0.2, 0.3. It took about, I think, almost a year.
Well, what's interesting is that the thing I actually thought was interesting about the definition versus a license is that a license tells you what you can't do. You know what I mean? It's putting restrictions. It's restrictive. Whereas the definition, I think, was just saying like what we like. And the wording of the wording of a license is usually much more strict. It's like you cannot, or you may not, or you will. You know. Yeah. Whereas a definition, what I liked about it is it was a little bit more fluid. It was like, you know,
this is the spirit.
This is the spirit, and if you want a license, the license may require this, but it doesn't have to. Like, you know, if you came with a license, people would be like, well, I want attribution, no, I don't want attribution. You know, like, so I think one of the things that was cool about the definition was we, as we were working on it, there was this kind of, you kept saying like, what can we live with?
Yeah.
What can we live with? I know everyone wants something.
Yeah.
Right. But what can you live with?
Because we reached some points where there was a lot of disagreement, and some people wanted to be very, very idealist, and some people wanted to keep it really, really simple.
Yeah.
And so basically, we started to really say, you know what, this is the goal of this is to fight the outside world who believes in patents and believes in patent and IP protection, and we should agree with each other to make it easier. And so we started saying, what can we live with, and ended up with a really good definition actually. And CERN in March of last year actually built their open hardware license based on our definition.
Right.
Yeah,
which was
we used it for our.
Speaking of, we just released our first CERN licensed product.
Yeah, there was.
Oh, cool! A little bit is the CERN license.
Okay.
Yeah. I really, personally, I think the CERN folks have done the best job taking the definition and turning it into a license, because they're very active, they've been involved with the community, and
they're looking at it from an international perspective.
That's right.
Which I think is very important.
And I like that it's not just U.S. centric.
Yeah.
Exactly.
Yeah.
So I have a picture of the open source hardware logo that's on so many boards. There's kids putting it on their school bags.
Yeah.
They're putting on
I got a
their
tattoo
PCBs.
of this.
You do not have a tattoo of this. But so how did this come about? Because you worked really hard on this.
Yeah, so after working really hard on definition, and that went out, we basically, on the Open Hardware Summit website, put the definition up and basically said, people please vote and put your name down if you endorse it. And people started endorsing it. And then I really think that design is very important, and I think that it's very important to make things sort of very publicly visible when you believe in something. So like whatever, if it's a T-shirt or a badge, like that's why I love these.
Yeah, you know, a symbol.
A symbol, yeah. So a symbol for the community to say for somebody to say that they are a part of this community. And so basically, we wanted to make a logo, and I didn't know how to make a logo, and I didn't feel like it had to be from a top-down approach. And so I launched a competition, and basically had a bunch of people submit logos that they wanted reviewed. And we actually, in about 3 weeks, we had something like 130 logos submitted. And some of them were awesome, some of them were less awesome. And then we had basically the community vote on it.
Yeah.
And the community voted on this logo, which was inspired by the OSI logo.
Yeah.
Okay, cool.
And then we tweaked it a bit, and so now it's clean and nice. But now it's basically on thousands and thousands of boards. And
Yeah, it's so exciting.
yeah, and PCB houses say, like, they asked, Nate once told me that the PCB house that he used, asked him, what is this thing that we keep seeing now in all these
At
boards?
Maker Faire, I counted no less than 4 companies that actually used the logo as part of their company.
Branding.
Instead of like the letter O.
Oh, really?
They'll use that
Yeah.
as the gear thing. It's interesting. It's everywhere. There's kids in the maker world that recognize that logo just as much as Disney or Coca-Cola or Apple or Nike. That's cool. So
we're
good
doing
work.
something right, yeah.
Good work. All right.
Okay.
So we're actually going to take a little bit of a break so you can have some water and catch your breath. And we're going to watch the Little Bits video, which is gorgeous.
Thank you.
So everybody sit back. It's a couple-minute video.
Yeah.
And it's a lot of fun.
Okay,
That was fantastic.
we're back.
Thank you.
That's a really nice video.
Yeah.
We just released this last week.
Yep. Yeah.
So it was made by an incredible team actually out of Brooklyn called Labor, and the really exciting thing is that the video is actually entirely built with little bits.
Yeah.
And so there's no stop motion, there's no After Effects, there's no kind of like, it's not faked in any way.
No, I like it, and you can actually tell, like, you're like, that is, because it's like, it's a little, not
It's
rough, but it's like,
jaggedy,
you can tell, it's like, oh, it's not like CGI, it's like, they are the real thing, so it's really cool. Okay, cool, so let's
it's amazing what a video can do, though, because you can, it's very hard to explain sometimes what these things do.
Yeah.
And someone in the chat said, oh, at first I wasn't sure about what I thought about little bits, but now they're like, now I want some.
Yeah.
It can go in 2 minutes.
Because it's been really hard for us to explain that they're little modules and they're not programmable, but at the same time you can combine them with material, and if you can't visually see it, it's really hard.
It is tough, it's a little abstract, it's electronics, and electronics are abstract.
Okay, we're going to keep moving along, so let's just talk about little bits. So,
okay, wait, can I like,
yeah.
I'm actually supposed to interview her.
Okay, we just, if you think you can get through stuff.
Yeah,
okay,
I'm going to interview her. So you want to put up this photo? What is this photo?
Well, this was,
oh, that's fine, okay.
So
click on this one.
Yeah, that's what I just did. Man, I was already on it.
Okay.
So.
I just didn't know if you had another photo. Okay. Enough of these men. So you were at the Media Lab, and I was a year ahead. So like I graduated, and then, did you work on little bits at the Media Lab, or you had the ideas there, or was it iBeam that you came up with the idea?
At the Media Lab, we worked on the number 6. Remember?
Okay. Yeah. Anyways,
that was open source hardware platform, but very different.
That was a dead end. Okay, so now you went to iBeam after that.
I worked in finance for 2 years.
So you worked in finance for 2 years,
and then I quit.
I was at iBeam. Okay, so I was at iBeam after. Actually, I graduated. I worked at like a startup for a little bit, and then I went to iBeam, which is open hardware / art / technology gallery. Atelier.
Yeah.
I don't know what the word atelier means, but
it's an art and technology center.
Yeah,
in
Chelsea, and so I moved to New York to start doing a 11-month fellowship there, and then I left, and then a year later you showed up.
Exactly.
So
I was telling you exactly.
It's cool because it's like I'm like, hey, it's Ayah, she's still here. So while you were there, you started having this idea.
So while I was there, I was doing some freelance work because you couldn't
pay very well.
You couldn't live off an iBeam salary. So I was doing freelance work and I was doing consulting. And one of the things that I was working on is to get designers who were industrial and product designers that work on consumer electronic products to integrate electronics earlier into their prototyping process. So you'd have these industrial designers that were working on cell phones or microwaves
and they're good with plastics and wood and cardboard.
And they mold things.
Yeah, and that they do.
But they don't know how to integrate light or sound or buttons, and so they would make these things.
They're like, I need a knob, and the knob does a thing, and it's like it's already too much.
And then and then it's different with a sketch, and they can't iterate, and then they have to give it off to an engineering team, and the engineering team thinks it's ridiculous because you can't fit a screen here, or you can't fit a battery, and so. So I was starting to work on this project, and Little Bit started by being these small cardboard pieces that I put together, and basically just to test this idea of what it would be like for them to be modular. Mm-hmm. And at the same time at iBeam, I was working on an art installation which was inspired by electronic panties made in Syria.
Yes.
And one of the underwear had an electromagnet in it.
Okay.
And I was doing the early version of Little Bits, and we were looking for connectors, and we couldn't find connectors that were really, really small but also instantaneous. And then I went to iBeam and I looked at these electromagnetic panties, and I was like, panties, Little Bits, panties, and then
yes,
it had magnets.
I see the connection. So you saw a similar connector to this one, and so that's when you came up with the idea, or is this based off of another connector?
No, there was no connector, just the idea of a magnet. So actually the first things that I was looking at were the magnet strips, like the ones that you have in fridge magnets and things like that.
Yeah.
We tested that for a long time, but they weren't strong enough, and you couldn't really do much with it.
So the thing that was, the things that got you thinking were, okay, you have industrial designers who are trying to do electronics, and they're like, they can't because they're industrial designers. Electrical engineering, so you were like, you want to basically create something for them that's so simple that they can just put it together, snap it together.
Essentially make it a material. Like for them, cardboard, wood, foam, plastic are all materials, and they grab them and they know how to work with them and they make something. And I wanted to make light and sound and buttons and sensors into a material of equal complexity.
Yeah. And then you had this idea for magnetics. Okay, so then how did you build your first prototype?
The very, very first prototype were cardboard pieces with copper tape stuck on them and through-hole electronics jammed into the cardboard and soldered on top. They were very messy, very ugly, but they were really, really a very important step to understand like how they modularly later work. And then I found these ring magnets at KJ Magnetics. That the ring magnets, and I would put the magnets in and put a screw through them with a nut on the other side. And then the next version after that, we kept working with the magnets, but then created a plastic shell around them, and then 2.5 years later made a connector.
So to get the connector made, because the connector, I mean, it's not the magic, but it's a little bit of like what makes it so cool.
It's a little bit of the magic.
That the parts snap together, and so. How did you design this connector? Did you find an industrial designer to help you, or a mechanical engineer?
It was a kind of a. So this is the connector that we're talking about.
Yes, we got some photos.
Oh, you have it, yeah. So the very early versions actually had 2 magnets, and the magnets conducted electricity.
Yeah.
And then the version after that was we wanted power, signal, and ground, and so we had 3 magnets. And they conducted electricity, but that was a really difficult process because you can virtually not. It's impossible to line up 3 things in the real world in a perfect form for them to make connection at the same time.
Okay.
And so that was dead end. And so now in the final version, you have 2 magnets that are just to hold them in place, and the actual conductivity is through these pogo pins.
Oh, very clever.
So is it actually a pogo pin? You basically go into a pogo pin factory?
Yeah, but they're custom made. Yeah, they're actually in this connector, and we have a new version of the connector coming out. In this connector, it's a pogo pin, and then the other side of it is this L-shaped solder pad, and they make contact, but they're not perfect, and it's still not very stable. And so the next version, actually, it's one piece, and it's much more stable.
Did you, when you were working on this, I know like it looks a little bit like a MagJack connector for
a MagSafe,
a MagSafe connector for. Is that something that was inspiring for you?
Actually, no. The early sketch,
because I think it came beforehand.
Early, I have early sketches from way before the MagSafe came out, or at least I found out about it. And so people always tell me, "Oh, you're gonna get sued by Apple." And
but you have prior art.
I have these sketches. At the time, I don't know if I don't remember if I had published the very early ones, but I published the first prototypes a little bit. So so if I get sued,
you'll be fine now. I don't know.
People will defend.
No. The thing that was interesting is I was thinking, like, wait a minute, like I remember you working on Little Bits way before. Yeah. This is 3 years.
The thing is, you don't know when Apple started working on it and when they patented before they released. You don't know. We can't.
This is the way I look at it. We're either going to hang together or hang separately. So if they come after one of us, I think they'll have to come after all of us.
Another thing is that their connector may not carry data. Like it actually might be a different. I mean, I don't want to get into details, but it can be different.
I think it's true. Yeah.
Okay, so the cool thing is that you've got these connectors and they snap together. And so you said there's 3 contacts. Power, and the power is what, like 5 volts?
5 volts.
And then ground, and then signal. What is signal? Is it like a...
It's just analog 0 to 5.
0 to 5. Okay, so the way you figured out is that, like, for example, this potentiometer piece right here...
You can go to the overhead.
Yeah, you want to go to the overhead?
Yeah. We have an awesome overhead.
I actually don't understand how this works. I'm interested. So you start with a power... sorry, you got the power supply. Yeah. You're all set. So you got the power supply, and purple means like power in or something?
So they're color coded. So blue is power, pink is input, green is output, and orange is wired.
Okay, so you've got this adapter, and then this plugs. Oh wait, I can't. It won't go. It won't go. You can't connect it backwards because the magnet
won't allow it. Exactly.
But then when you get it right, it flips this way. So now there's a potentiometer.
So you need something to control
the output.
The potentiometer to control something. So you put in output. So
well, how about this buzzer? Or is this a vibration?
It's a vibe motor, yeah.
So, it is a vibe motor. Okay.
Yeah.
So let's. Whoa. Well, you can't see it, but it definitely is buzzing. And then, it buzzes less. It buzzes more. So maybe I can put this on here so you can see the buzzing. So it's buzzing a lot, and then can you turn it the potentiometer? All right. So then down. So you figured out how to make it so each input controls an output.
Exactly.
What happens if I connect another output to here?
So each one of the output modules is actually buffered. So it takes the signal from the signal line, but it also passes it through to the next line.
Okay, so this is RGB. This one's confusing. Let me get the the LED strip. So then I can turn this up. Oh, sorry, turn this up, and more LEDs will light up, and the vibration thingy goes crazy. Or I can turn it down. So this input can control multiple outputs.
Exactly.
I have another question. I'm gonna ask deep engineering questions. What happens if I connect the outputs without an input?
It's just on.
It's just on.
Yeah.
Okay, so that's a way to just, if you want to just have a light or something, or like
we've seen people make projects that have, for example, a small personal fan or a desk light or something like that, and you can just have an on-off switch and you can just have it go.
Okay, and then what if I connect an output? So this is the buzzer, buzzing, and then the input, and then this. So this controls only this guy. So it's smart.
It's only directional, exactly.
Yeah. So the signal only goes down here. So if I turn this, it doesn't change the motor. It only changes the LEDs.
Exactly.
Okay.
So the connectors are polarized, and the current is flowing through in one direction, and so you can even put two input modules one after the other. So if you put this dimmer, you put a pressure sensor after it, you'll have one modulating the second one.
Oh, okay. Well, let's put one potentiometer here, so I can now control this. Oh, and then it multiplies it.
Exactly.
There's a multiplication capability. Okay.
I'm going to insert some quick questions as you guys are doing stuff, because we have about 15 minutes or so.
Yeah, but this is a good demo. I want to
someone
show
wants to
stuff.
know, is there a microcontroller on every board?
There is no microcontroller. It's all
No,
analog electronics.
analog,
It's
like
all
a real
analog.
engineer.
I knew you guys would like that question.
I'm a big fan of analog electronics. I think people have started to put microcontrollers on projects too fast, and sometimes it's overkill. A lot of times it's overkill.
Yeah.
Microcontrollers are expensive. They need to be
They
programmed.
break.
They break. They need to be programmed. They're sensitive to ESD more than a lot of these parts that are more.
Your supplier goes,
I mean,
your
this
supplier goes
analog-ish
out of
has an
business.
op amp and an op or something, right?
Exactly. They have op amps on them. It's usually all resistor ladders. It's capacitors. It's really simple stuff. And
So this is a squeezy sensor.
Someone wants to know if there are Zener diodes.
there are Zener diodes on the power boards, yes,
Okay.
but not on the other boards.
Yeah, this is cute. So it's like as I squeeze this, it just so there's a little comparator or something here.
Here it's a resistor ladder actually.
Okay, nice.
And then we have some new modules that we put out also that are AND and OR gates. So we're really kind of going back to basics, because I think it's really useful to get kids, but also adults, even people who program and don't necessarily understand the concept of AND and OR. They're able to now play with them as individual modules, and it's actually a really useful thing.
Yeah.
Okay, next up, going to do some questions as you guys are talking about this. Is this an open source project?
This is in fact an open source project, as is evidenced by this logo right here. You can go to our website littlebits.cc. If you go to the bits you can go to our GitHub repository and actually download the design file.
That's great.
Yeah.
We like using GitHub. We use it for all our stuff.
Yeah,
That's
it's
nice.
cool.
And from what I understand, you brought something special to show everybody here tonight. Is that true?
I did.
Is this a world premiere?
This is the world premiere.
I don't even have world premiere music. Man, I gotta get that.
Okay, I'm going to
Alright,
put
show
this
the
back.
world.
I
show
want to put
the,
well, I want to put this back all nicely.
Okay.
So sorry, 1 second. Okay, this is all nicely put
someone wants to know if you have inverting modules to give a reverse input. Are there signal splitters?
We have signal splitters. Do I have one here? Do I have? No, I don't have. Oh yes, I do. This is a branch module.
You can show it underneath here.
This is a branch module. It has one input and then 3 output sides, so you can have multiple outputs.
It's like a fan.
And like this is a DC motor, and then you can have, for example, what can we put?
Sorry,
Well,
how about this little fanny thing?
Yeah, or like a fan. Well, now we're going into the second announcement, but anyway, we'll show
Yeah.
you.
Sorry.
So this is oh, I can't get it right. Magnet. Okay, here we go. So now, you have this branch module, and you're able to branch out and have an LED, a bar graph, and this fan, and the fan is controlled by the sensor. And we also we're going to do some that are 3-dimensional, so that go up and down. You can make some things that are more structural.
Oh, nice.
So here is
Motion sensor.
a motion sensor,
Yeah.
so you can connect.
So this is
Yeah.
very sensitive, actually. The motion sensor is extremely sensitive.
Yeah, I'm sure. Well, it's also like the lights here are crazy.
Yeah.
Let's find one that's. Oh, how about the switch?
This switch is very cool. Actually, it's a roller switch.
Yeah, we have these roller switches.
Um,
So this is a roller switch.
So see, this is the finicky thing that I was talking about. It's a roller switch.
Is there a time limit on the sensors?
No time limit.
No time limit.
Sorry, is it a connection thing?
It could be like, it could be dirt. I kind of threw this together.
The difficult thing about magnets sometimes is that they pick up a lot of dirt, so sometimes it's hard. So this is a roller switch. So it's normally on, normally off, and then you have this little switch here that says normally on, normally off, and you can flip it. So you can do the opposite.
Yes, let's connect this one to the LED. There you go. And then,
Oh, that's fun.
yes, that's easy. And then you can have...
Look at you, you're having good
yeah,
time.
no, I'm trying to...
If
get
the
this-
more free it is having good time a little bit, then we know it's a good thing.
Okay, so you got the thing, and then you've got the squeezy, and so you can squeezy and clicky.
Exactly.
You're gonna have to leave those here. So tell me about
So the idea here is that
this new one.
you have, okay, so you've got these new modules that I'm kind of showing off right now. So tell me about these new modules.
So you're already showing off new modules that are actually part of this new. How do we show the kit?
Well, let's go to the big screen here, and I'll show this.
This is MegaBits.
Yeah. So here,
So let me
show
put
them.
some of
Show
them
them.
down.
Show them here. So
Okay.
this is MegaBits.
This is so actually
you've
that's
got-
a good name. We should have called it that, but it's not. It's called the extended kit.
Okay.
So let me put some here.
So you've got the fan output, which is really cool. So this is because you can blow out a balloon or like a bag.
You can, yeah. We have a project, so I'll tell you a bit about.
Yeah, and you're gonna maybe
A
show a
DC
couple projects too.
Yeah, we
Okay.
have a few projects.
A
to show.
DC motor.
So this, the extended kit has 14 bits in it. The starter kit, which was the first kit that we put out, had 10 bits in it. The extended kit has some of the more complex things. So it has the branch, it has a DC motor, it has a long LED,
Wow, it has a buzzer.
it has a buzzer,
It
which is
has
actually
a-
very popular.
has a slide. Well, kids love annoying noises.
It has a slide dimmer,
Slider, USB power.
USB power. You can still use it with a 9-volt battery adapter as well, but
Light.
USB power.
Oh, that's great. So you
Light
can
sensor.
use your computer.
You can use your computer.
Yeah.
Exactly.
Light sensor.
You can use a
this-
Minty Boost, huh?
You can use, yeah.
It's got a little switch, a
The
nice switch.
toggle switch, and the idea is that if we have enough diversity in the modules and the components, you're able to make projects that are actually cool and where you hide the electronics or not, depending on what you want to do. So this extended kit actually comes out in 2 weeks exactly. So this is a sneak peek, very special sneak
Okay.
peek for the Adafruit
Okay.
pen.
This is great.
Yeah.
All right, we're gonna try to get through this, and then we're gonna have to we're giving away a prize we do at the end of the show, and then we have a cat. So you brought a couple projects. Can you show
I
these?
brought a cat.
Yeah. Oh, you brought a cat?
Yeah.
Oh, okay.
So,
Okay.
so
Wait,
this
so-
is our MOSFET.
Yeah.
So this is a cat that was made. Can you see? This is a cat that was made by a 6-year-old in a workshop that we had in our office. She had never played with electronics before, and she thought that she hated electronics. But after a couple of hours with MegaBits, she actually made this project. There's a pressure sensor in the tongue, 2 LEDs in the eyes, and then a DC motor in the tail, and the vibration motor in this Christmas bell. And oops, this is
Yeah, the tail spins.
this tail is getting stuck on the head. Yeah.
Okay. So when she presses it, the lights turn on, and it turns the DC motor, which is connected to the tail, and also the buzzer, which is, or the vibration motor, which she's stuck inside.
Inside the Christmas bell.
Oh, I see. Yeah, the little wires. Okay.
And so, would you say that these are geared towards younger kids? Because I've seen adults playing with these a lot. Like
I haven't seen these. They're all mine.
But I do see a lot of photos on Flickr and Twitter of kids playing with these. Would you say
We've been trying to push them a little bit more towards kids. Actually, adults really like them, but we're trying to get more kids interested because they require no programming, no wiring, no soldering, and so you can get kids as young as 2 really to start playing with this
Yeah,
stuff.
I saw a 2-year-old put together little bits, and I
Yeah.
was like, "This is the future."
And then it's really nice because they start to understand different components and how things work, and they start to like look at the cell phone and understand why it vibrates, or they look at a switch, in a room, for example, and they
Oh, it's
understand
like,
why
it's
the
just
switch
like,
comes on.
it's
Yeah.
just the same as the,
Exactly.
All right, so what's this thing over here?
This is another project. This was not made by a kid, actually. This was made by our office manager, Jen, who had never touched electronics before and was very afraid of electronics. And we had an event at AC Gears where we gave away prizes, and this prize was a wood kit. It was just a bunch of wood material that came with a little bits kit. And so what she did here is she put a dimmer, she put a DC motor here, and then when you connect power, basically what you can do is you can turn the dimmer on and you can have the windmill go off.
Oh, and it's got a nice green light too.
And it has an RGB, is it an RGB LED? Yeah, it has
Yeah.
an RGB LED in here also. So it's a very simple project, but again, a project where she hid the electronics and she made something really cute, and they're actually here in the back. And diffuses the light. Yeah. So they're very simple projects.
I like the addition of like craft. So it's like it's part of like, oh, get some popsicle sticks in little bits. You know what I mean? And then when you're done, you can just recycle the little bits.
You can you take them out, you recycle the little bits, and then the nice thing is that you're able to be as crafty and make as finished a product as you want. We've made things where we've laser cut all the parts and we've made them really clean and polished, and we've made things where it's literally straws and popsicle sticks. Yeah.
Okay, and when people want to buy these, of course they can, when they're in stock at the Adafruit store, where else can they get these?
They can get them at the Adafruit store starting Monday.
Yeah.
They'll be back in stock. Oh, there's a switch. Yeah.
But what other places online?
So you can get them on our website. We've actually been selling much faster than expected, so we're trying to keep them in stock as much as possible. We also sell them at the Maker Shed, at Spark Fun, AC Gears, and Fat Brain.
And at AC Gears in New York, you can go there in person and buy them, right?
Yes, you can go. Now they have a wait list actually, but we're going to be replenishing the stock soon.
Well, if you don't mind, we're going to try to get through a bunch of questions so that you can answer these fast, because this was a...
If the questions are wrong, I'm going to...
Okay. Well, I'll put these out of order. What's in the basic kit?
The basic kit is called the starter kit, and it has 10 components, which are listed right here. It's the power module, the dimmer, bar graph, LED, wire module, button module,
pressure sensor,
RGB LED, pressure sensor,
bar graph
reset, and vibration motor. So 10 bits, and then
a wire
also
thing. There's a nice little wire connection you can extendo between the bits.
And our very cute screwdriver. Because the pulse module, we didn't mention the pulse module. The pulse module is a 555 timer actually, and you have a little trimmer that you can rotate with the screwdriver so that you can make it go faster or slower.
Okay. And what determines the pricing of these? Quantity, because you have to get these made. Like, where the costs come from when you work on a product like this?
So our biggest cost right now, so we have a lot of upfront costs because the magnetic connector has to be tooled. So we buy actually the machine, the tool that makes it, and that's a big upfront cost. But also when we make small quantities, we're basically paying for the setup of the machine over that small quantity, so it ends up being expensive. And so the first couple of runs, the first run we made 200, and they were very expensive. They were $130 a kit because our cost was so high. Then we started making 500 at a time, and our cost started coming down, and now and then 1,000 at a time, and now the next run we're making 10,000. So the goal is to try to get the price down so that it's more accessible.
So the first run costs more than the kit.
The first run will cost more than the kit. Yeah.
Wow.
Okay.
Yeah. This is why I always warn people. I mean, like, you knew what you were getting into. But a lot of people who think that, they're like, oh, I'll do a small run, and the cost can't be more than XYZ. You'd be surprised. Like, it can bite people who are not expecting it, they don't have a plan.
And whatever price you have in your head, you have to double it, and then on top of it account
if you want resellers,
and then on top of it account for whatever profit you get, because you're gonna be off in pricing.
You're always
how good
off.
you are.
It's always off.
Okay.
That's why Kickstarter scares me a little
next
bit.
up, are you developing an electronics curriculum for children based on Little Bits?
We are actually. We're starting to seed it. So we're a very small team. We're only 7 people, and we don't have any educators on the team yet. But we're working to start. We're trying to start working. We're trying to start working with some educators. We have a part on the website called the community platform, where there's a learning tab, and you can click on the learning tab and upload lessons. So we've started to seed that, and we get a lot of email actually and inquiries from schools all around the country and the world wanting to incorporate into their classroom. So at the K level, at elementary level, high school, and even at universities. So universities like RISD and Stanford and places like that are wanting to incorporate.
And Little Bits is doing pretty well, and you're hiring people soon. What positions, because we have a lot of engineers, a lot of awesome people that watch the show, what positions are available at Little Bits if people wanted to join this awesome, it's not only a cool product, but it's a cause. You're working to help the world and educate people.
We're very mission driven, and we love what we do, and we're looking to grow the team. So we're hiring superstars basically. Community manager, we're hiring electrical engineer, electrical engineering intern, video and documentation experts, software and web developers, and what am I missing? Yeah, that for now that's it.
Okay.
Yeah. But the one we're most excited about is more engineers, because we want to put out more modules and start to roll them out faster.
The audience wants to know, how can we help get these into schools?
What you could do that would be great is we have an education discount for schools. So if you identify a school that's interested, put us in touch with them, or go ahead if you want to get in touch with us, and we can give you education discount. And if you can get them piloted, at least in the class, and get the teachers and the kids convinced that they can benefit from that, then they can start rolling them into their program. We basically just want content and feedback, and we'll roll in whatever feedback the teachers have, and we'll produce modules based on their feedback, because that's ultimately what we're trying to do. We're trying to improve education.
Yeah. And this isn't a question, but just a comment from me. This is so cool that this is one of 5 or 6 open source hardware companies in New York City.
They're a growing number of us.
Adafruit, MakerBot. I mean, like, it's fantastic.
I mean, New York is really great because there's a lot of talent here, and there's a lot of hustle, and I think you need talent and hustle to make a startup work, so it's good. Yeah. And Silicon Valley has all the dibs on software and apps and all these things, so we should keep hardware.
Yeah, it's interesting. A lot of people say, like, oh, well, you can't do hardware in New York because people aren't making, there's no manufacturing space, but ironically, there's no manufacturing being done in California either.
Nobody's manufacturing in California.
Yeah, so it's like, in the end, it's like, it actually doesn't matter where you are. It's like, I mean, Apple had to start in California because they actually had factories in Fremont, but now they don't make stuff in California.
They could be in Paris.
I mean, it's close to China, but, like, honestly, in the end, like, this is where the stuff gets made. So it's cool. You can actually be in New York and manage manufacturing being done, wherever.
The nice thing about New York,
California or whatever, New York or.
The nice thing about New York is it's closer to the rest of the world. So we have closer contact with Europe. We have closer contact with a bunch of other places because we're just closer, and so it's easier. Like we get visits from people that are coming from the UK or from Paris for a weekend, and they come to New York for a weekend, and they could do that, but they can't do that when you're in California.
Yeah, another nice thing is that when you're in New York, the media here, it's easy. Everyone visits.
Yeah.
People are like, oh, why don't you come and visit us in Pennsylvania? And I'm like, well, you're here, right? So
people always ask us why we're in New York, and we work really hard. You have to hustle, as you said, but at the same time, everything comes to New York. You can constantly be inspired. All the best art, all the best science, all the best music, everything comes through.
Gives you energy, yeah.
And if you're doing these things and you're going to devote your life to teaching and helping, you have to be inspired.
Yeah.
You can't just turn it off at 5.
No.
You have to go. Like one night we were so tired and exhausted, and we happened to get tickets for a Philip Glass concert. We walked there and saw it. Amazing. We work on open source hardware, and then we see something like that live. It's like he's not going to be playing music forever.
No.
It's fun. So it's a cool city to live in. It's tough though.
It's tough. Yeah. The hustle and it's tough.
It's tough.
It chews you up a little bit. Well, we should do the quiz.
Yeah,
it's 11.
Yep, we're gonna wrap up the show in just a minute. So thank you so much. People were putting in good questions. That was great.
Thank you so much.
Really
Thanks a lot.
So we're gonna do a trivia question, and what we're gonna do is, if you win, we'll give you a Little Bits kit once we get them in stock. Just don't have them
after
right
Monday.
now.
We'll have them on Monday or Tuesday.
So can you tell the rules?
The rules are, if you've ever won something on the Adafruit trivia quiz question thingy, you cannot enter this contest. We want everyone to have a sporting chance. So even if you really want a Little Bits kit, please sit on your hands or type into another window. You can always buy a kit. The first person to answer the question correctly with spelling as we desire it, and we see it in the window, is the winner. And we'll ship you a Little Bits starter kit when we have them in stock.
Yeah. I'm going to ask a question.
You're going to ask the question?
Yeah, I always have to get ready here because it's always... Okay, first person to...
But please try, especially if you have a kid or you know a kid that
only win these if you're going to do something cool with the kid and do stuff. Okay, in November of 2011, Little Bits was added to a specific MoMA collection. What was the name of the collection, the show, that it was added to? So this was MoMA, 2011.
I'm interested.
What was the name of the collection, the show, that...
It's not the cat. The cat's not the answer.
There's some fast Googling going on right now.
think it's so much fun.
It's addictive.
Yeah.
The name
Why'd you take it from
of
her?
the show at MoMA that
It's
Little
the
Bits was
battery.
added to.
Oh, she donated.
Oh, yes, Kinger, you got it. It was Talk to Me, and then everybody did it. Yeah. And so that's
Yes,
another thing.
Kinger.
Your work is at
It's part of the permanent
was part
collection.
of the MoMA, right?
I like to think that it's next to a Picasso.
Yes.
Yes, that's
They,
what I-
it actually, they put holes in the Picasso and they put the LEDs in and they
Exactly.
attach a bell, and then when you poke it,
exactly.
Okay, so we're gonna just run 1 minute over, but why don't you guys talk amongst yourself? We have to show this live cat.
Okay.
So I'll be
Okay.
right back.
So, what is the future of Little Bit? Let's talk about the future. So, we have more modules.
More modules, that's the biggest thing that we're focused on right now. We want to start to do things that are more structural, so things that are three-dimensional, that you can branch out. And we're working on something that's wireless, so that you can have your power module on your controls somewhere, and you can have output modules somewhere else.
Yeah.
But we actually have a lot of the simpler modules to roll out first.
Have
so
you ever thought about integrating computer control, or are you purposefully not adding computer control?
We're trying to stay away from the tethering to a computer as long as we can, and we will have to at one point, and we're going to make microcontroller modules and screen controls and stuff like that. But a lot of people are already doing it, and it's, you know, they're doing a very good job with it, and I think analog needs some love still.
Okay, so here it is. Everyone wants to talk to him.
MOSFET? You know,
MOSFET.
he's interested.
Oh wait, turn it on.
Oh, yeah.
I'm very battery focused.
Oh. All right.
It's not happy with the competition.
No, he doesn't have a pressure sensor. All right.
Poor cat.
Okay.
Oh, he's furry now.
So
He's
that's
very
it.
happy, despite the scary
Special thanks to
cat.
George,
Yeah.
who does our recording, Paint Your Dragon, Phil Burgess, who stopped in, John Janier, who's always helping out with the show, Becky, who was in earlier doing some stuff. Of course, the awesome audience. There's a lot of people here tonight. You have a lot of fans. Someone want to know,
Thank you.
how can they learn more? What's the website?
www.littlebits.cc.
Right. And on all the like social networks and all that, is there Little Bits?
Little Bits, yeah. So we're Little Bits on Twitter, we're Little Bits on Facebook, we're Little Bits on Instagram, although we haven't started putting pictures up yet. But you can tag your photos and we'll roll them into the website. And yeah.
Okay. And you're always kind of speaking at events. You did an awesome talk at TED. What do you know what the next event that you're going to be at is?
I think I'm trying to take a break because we have to focus
Yeah.
on rolling out new products, and so
Yeah.
the next thing will be the Open Hardware Summit.
Okay. Yeah, we had to do that too, and so we do a show every week, and you're always welcome to not only stop back, but be on the show and tell.
Thank
if
you.
you want to tune in. And
We'd love to. Yeah,
yeah.
I'd love to.
We have a live cam here. Okay. Well, everyone, we'll see everyone next week. Thank you once again. That was fantastic.
Thank you.
Ayah has one of our favorite companies who's doing great stuff.
The cat can totally do little bits. He can put stuff together.
We have a cat on the side. She sent us a picture of a cat playing with it, and we have a dog, a bulldog too.
Really?
Yeah.
All right. Well,
It's easy enough for MOSFET to use.
good for everyone.
All right, this is awesome.
All right. And with
Thank
that,
you so much, guys.
here is your moment of Zener.